Hello and welcome. We're going to be talking about Newton's first law, just some quick demonstrations. If you were in class the other day, you got to do at least one of these demonstrations. So I'm going to start with the card trick. So this was to illustrate Newton's first law. And what we did is we just took a cup, an index card, and a penny. You can use any kind of sturdy piece of paper and just cut it so it's small enough to where you can flick it, or some people do better if they pull it toward them. So it's just kind of your style. And the idea is if you flick it or pull it quickly enough, you're going to get the penny that's on top of it to fall straight into your cup. So I'm going to try it here, and I like to flick it really hard. All right, it dropped right in. I had been advising some classes to just flick it gently, but it actually works better if you flick it firmly. And then the other way to try this trick is to pull the index card towards you really fast. You want to do it really fast and try to get the penny to drop in there. So I'm not as good at that, but that's another way you can try it if you're not having much success. The question is, why is it when I flicked that index card, why did the penny fall into the cup? I mean, wouldn't you think that the penny would be dragged right along with the card? Why does it fall straight into the cup? Well, it has to do with Newton's first law. All right. The other trick that I wanted you to try, that you can try at home, is taking a coin like this, and you want to grab it really fast, almost like you're cracking a whip. You don't want to bump it up, because that's not really a trick in that case, because you're putting it up in the air, and that allows you time to catch it. The idea is you just want to snatch it right off your elbow. So notice my arm position, and I'm going to try to catch it. Oh, I didn't get it that time. I'm going to try again. All right, there, I caught it. So again, I didn't bump it up. I just tried to catch it real fast out of midair. So again, how is this possible? Because no matter how fast my reflexes are, if I'm able to grab that coin, if you really think about it, that means that coin has to hover in the air for like a fraction of a second, allowing me to grab it real fast. So it really does, actually. It does hover in the air for a fraction of a second, and that's because of its inertia. Remember that we learned earlier, it was an assignment we did during week 10. There was a video I made about Newton's first law. If you haven't done that, you absolutely need to do it. But there's a video I made. We talked how inertia is the tendency, so like a habit, the tendency of objects to resist change in their motion. So when the coin is on your elbow, its inertia makes it not want to move. It wants to stay at rest. So its inertia allows it to hover in the mid-air for a split second, like a small fraction of a second before it starts to fall. And if you're fast enough, you can take advantage of that and grab it real fast. Your job is going to be to explain, how did the card trick work? So how was I able to flick that card and get my penny to drop straight into my cup instead of being dragged along with the card? Other things to think about as some extension activities would be, why does a coin of a greater mass seem to work better for this trick? I had a few students ask to try some heavier coins. All I had were nickels. So if you have a heavier coin like a quarter or a nickel, you could try that and see. A lot of students tell me, in my experience as well, it seems easier to do the card trick and the coin grab if you use a coin that has more mass. So why would that be? I'll see y'all soon.